All right, so we're almost done with this chapter. We're on page 15 of 17 in chapter 10. So we're going to revisit reliability, which we talked about like in week 1 when we did chapter 2. So we were introduced to the concepts of reliability. Reliability is a measure of consistency. We saw 4 different types of reliability. So we saw test, retest, inter-rater, parallel forms, internal consistency. There are numerous ways to address each type of reliability, but correlations are often used. So let's look at how correlations can be used with each type of reliability. So with test and retest reliability, this will assess the stability of scores over a time period. So by administering the same test to the same group of individuals at 2 different points in time, we can calculate the correlation between the 2 sets of scores. So a high correlation indicates that the test produces consistent results over time, demonstrating good test or retest reliability. Inter-rater reliability. This measures consistency between people who are providing the score. So when measurements involve subjective judgments such as observational studies, inter-rater reliability is crucial. This type of reliability is assessed, by having multiple raters evaluate the same thing and then calculating the correlation between their ratings. A high correlation, between the ratings suggests that the raters are consistent in their evaluations, indicating good inter-rater reliability. Parallel forms reliability. This involves creating 2 different versions of the same test, both intended to measure the same construct. It is common for researchers to create different forms of the same assessment, in an attempt to prevent cheating and to help reduce repeated testing effects. The 2 versions are administered to the same group of individuals or students or something, or patients, and the correlation between the scores on the 2 forms is then calculated. A high correlation indicates that the 2 forms are equivalent and that the test has good parallel forms reliability. Finally, we have internal consistency reliability. This is used with scales that are constructed from lots of different parts that perform similar functions. So for example, the statistics anxiety relating scale, or STARS, consists of 51 items that are assigned to 6 different subscales that measure different aspects of statistics anxiety, The test developers computed Cronbach's alpha has a measure of internal consistency for each subscale. So you spell Cronbach's alpha as C-R-O-N like Nancy, B like boy, A-C-H apostrophe S, Cronbach's alpha, and it's C like cat, Cronbach's. So let's say Cronbach's alpha calculates the average correlation among all items on the scale, or in the case of the STARS, the statistics anxiety related rating scale, they might calculate the subscales, right? So a high Cronbach's alpha indicates that the items are measuring the same underlying construct and that the test has strong internal consistency. Understanding the relationship between correlation and reliability is essential for developing and evaluating psychological tests. Reliable tests ensure that the results are consistent, right, and dependable, which is a prerequisite for establishing validity. So without reliability, the validity of a test cannot be accurately assessed. So let me say that again. Understanding this relationship between correlation, which is what we talked about in this chapter, and reliability, it's essential when you're developing and evaluating psychological tests. So reliable tests ensure that your results are consistent, dependable, right? You could replicate the data, which is a prerequisite to establish our next subject, which will be when we revisit validity. So without reliability, then the validity of the test cannot be accurately assessed, right? As inconsistent results cannot accurately reflect the construct that was measured, right? So let's move into section 10.6. We're going to revisit validity. The concept of validity was introduced also back in week 1 when we looked at chapter 2. Validity refers to the extent to which a test or a measurement accurately reflects the concept that it was intended to measure. So we are revisiting the concept of validity again here because correlations are often used as evidence in discussions of validity. All right, so for example, construct validity involves evaluating whether a So for example, construct validity involves evaluating whether a test measures the theoretical construct it claims or aimed to measure, right? Did the study measure what it sought to measure? So one way to assess construct validity is through convergent, and discriminant validity. So convergent validity is demonstrated when a test has a strong positive correlation with other measures of the same construct. Indicating that they are measuring the same underlying concept. So here's an example. If a new test for anxiety correlates strongly with established anxiety measures, that would suggest good convergent validity. This means that the new test is likely measuring anxiety accurately because it aligns well with other tests that are already known to measure anxiety. Discriminant validity, on the other hand, is demonstrated when a test does not correlate highly with measures of different constructs. So for instance, if the new anxiety test does not correlate strongly with tests measuring unrelated constructs like depression or self-esteem, it would suggest that the anxiety test is specifically measuring anxiety and not other psychological traits. This helps to ensure that the test is focused on the intended construct and not influenced by other factors. Correlation coefficients are used to quantify these relationships, which will help the researchers determine the construct validity of their tests. All right, so we're now on page 16 of 17, and we're going to summarize chapter 10. So at the beginning of this chapter, we reviewed scatter plots, which are often used in conjunction with correlational analyses to visually represent the relationship between two variables. Okay? We focused most of our attention on Pearson's R, which is the most commonly used correlation coefficient in psychological research due to its ability to measure the strength and the direction of linear relationships between two interval or ratio level variables. We also explored other correlation coefficients, so we went through Spearman's rho, Kendall's tau, which were used for ordinal data or when the assumptions of Pearson's R are not met. Additionally, we discussed the phi coefficient and Kramer's V, which are used for categorical data. We also covered special correlations, and those were applied with particular types of data. Correlations are frequently used in psychological research to explore and to quantify relationships between variables. So at the end of this chapter, to review, we examined how correlational methods can be used to evaluate reliability and validity. Reliability, again, refers to the consistency of a measure, and we discussed how test, retest, inter-rater, parallel forms, and internal consistency reliability can be assessed using correlation coefficients. Validity, again, which we learned in chapter 2, refers to the accuracy of a measure. Okay? And we explored how convergent and discriminant validity can be evaluated through correlations. In our next chapter, we will build on what we learned here as we delve into regression methods. Regression analysis will allow us to not only understand the relationships between variables, but also to make predictions based on these relationships. And that will conclude chapter 10.